Hey guys, so today we're going to be graphing this parabola. There we go. So we're going to graph this. So first thing we're going to do is find the vertex. So the vertex is going to be at -3 and 1. So vertex is at -3, 1. Right, we've changed the signs on both of them, just like we've been doing. So we're here at -3 and 1. This is my vertex. Okay, so then the next thing I'm going to do is I'm going to find P. So remember, P is the distance from the vertex to the focus and or the directrix. So this number here is 4p. So I'm going to just do the absolute value because I'm going to treat this as a distance, and I'm going to figure out the direction based on this negative, but I'm not really going to care about it when I'm solving for p. So p is 16 divided by 4, right? Because 16 equals 4p, right? So whatever number you have here, you're just going to divide it by 4, and that will give you p. So that's just going to be 4. So p is 4. And before I draw my focus and my directrix, I need to decide which direction my parabola is opening. Up, down, right, left, what is it doing? So y is what is squared, which means this is a right or left opening parabola. And there's a negative here. So if there's a negative, then it's going to open to the left, right? It's going to open in the negative direction. So this is a left-facing parabola, and P is 4. So I'm going to go left 4, and this is my focus. Okay? Left. I decided it was opening left, so I go left 4 from my vertex, and that gives me my focus. I'm going to go right 4 from my vertex, and that's going to give me my directrix. So I'm going to draw a dotted line. That's my directrix. Okay. So I have my focus, I have my directrix, I have my vertex. I just need some points so that I can draw the parabola. So I'm going to use the fact, right? Remember we talked about the latus rectum and how if you're in line with the focus, then you can just go 2p in either direction because I'm 2p away from the directrix. So I'm going to go 2p. So 2p is 8, right? Because p is 4, so 2p is 8. So I'm just going to go 8 up. And I'm going to go 8 down. I'm going 8 up and 8 down. And these points have to be on my parabola because I went 8 up. I went 2p up from the focus and 2p down from the focus. So these points are 8 away from the focus, and they're also 8 away from the directrix. You can count it, right? So they have to be on the parabola because they're the same distance, perpendicular distance from the directrix as they are from the focus. So they have to be on the parabola. So these are my points. And now I can draw, and we know kind of what a parabola looks like. It's probably way steeper than that. I probably went off the screen way sooner than I'm showing, but this is the basic shape, right? So that's a parabola. One thing that I want to mention, just because I think it's interesting, The further away the focus is, so in other words, the bigger P is, the wider the parabola is going to be. So it's going to open up wider and wider the further away P gets. So often you'll see P really small, like 1 or 2 maybe, and that's when you get those tight parabolas, very steep parabolas that we're more used to dealing with. But remember in the last video when I was talking about a satellite dish. Satellite dishes are really flat. They're really flat. Obviously, they're still paraboloid, but they're really flat. So that's why the antenna is so far away. Like those antennas are pretty long, right? If you're thinking you're putting the antenna at the focus of a paraboloid, it might seem like, wow, the antenna of a satellite dish is really kind of long for being at a focus based on what we're seeing here. And that's because it's a really flat paraboloid. And of course they do that so that it can pick up as many signals as possible, right? The flatter you make it, the more surface area you're picking up those signals. But anyway, I just thought that was interesting. I hope that helps, and I will see you in the next video.